Okay, hello, welcome to this stream, part 2 of the Graph View API deep dive. Part 1, if you haven't seen it, is already available on the channel. In that we went through the process of setting up all the sort of boilerplate stuff to just get a graph view window working, and we explored sort of the basis of how we're going to create nodes for the graph. And today we're going to sort of continue what we were doing from there and hopefully get a working system up by the end of the stream. It's going to be about 2 hours long. Hello to everybody watching. Thank you for joining on this. It's really dark and gross outside here in Vancouver today. So whereabouts are you guys watching from? Let me know. Would always love to hear where people are sort of tuned in from. It's such a great insight into how far this stuff goes. And yeah, I hope this is going to be helpful. Also, let me know in the chat if you were in the last live stream, and or if you've watched the video, and if there's anything you want to know that I didn't necessarily cover in the previous video. So it looks cozy. It does look cozy. Yeah. So can I stream in 1440? I don't know if I can change those settings while I'm streaming. So maybe if I have to do another stream, I would do that. I don't know if I can. Yeah, I don't think I can edit the settings while I'm live. I'm not sure. Yeah, I think I'm only streaming in 1080p. Next time I stream, I'll look into outputting at 1440 so that it's slightly high quality. So the last two live videos. Well, thank you for joining me on both of those. I appreciate that. Watching from Morocco, I think we're GMT +1 here. Okay, cool. Yeah, it is 11:30 a.m. I'm based in Vancouver in Canada. Spain, Romania, brilliant, amazing, awesome. Thank you so much for joining. Yeah, it's great that you were able to watch the last one, and thank you anybody who's watching this after the fact to join in for part 2. Sort of long form multi-stage tutorials aren't necessarily a thing that works for the actual content format, which is kind of why I wanted to do it as a live thing. So USA, okay, well, cool, awesome. Right, so I think what I'm just going to do is kind of cover some little adjustments I've made. It's just a couple of things, and then we'll dive into it because we got to a pretty good place last time. The package for this is available on the Patreon page. I uploaded it a couple of days ago. So if you want to start from this position, I'm basically I've got a Patreon post that is the most recent as of this video that will have all of the packages for each of the streams. So each stream I'll export the current state of affairs, and then so you can sort of see the snapshots from there, because I think we'll probably end up doing a third stream. I'm going to go for about 2 hours today, and hopefully we'll get enough done, but I think there'll be a lot of other little caveats that I want to show off. Because as you can see, we're sort of trying to replicate some of the feature sets. I just moved a bunch of things, freaking misclicking. We're trying to replicate a bunch of the features that I've added to my old mesh graph. I say old, my current but quite intricate mesh graph tool. And we're not going to go too much into this today, but there's things like a blackboard editor. There are also like macros that we have. I don't know if I can add them via my system here, but like, yeah, there's oh, maybe I can. No, I don't think I can. Anyway, oh, it's not in this project. That's why there's no macros. But yeah, so we're going to go through things, and as always, I'll make mistakes because we're live, and we'll just go through this together. So I think if you have any questions, then by all means, please feel free to ask them. I probably won't answer them unless they're sort of immediately relevant. But I will answer them at the end of the stream. We'll do a little Q&A like we did last time. So I'll go through and answer any questions. So feel free to ask them any question you want, of course. Like, but yeah, I think I just want to dive in, get stuck in, make the best use of this time. So just give me a second to have a drink, and we'll go from there. Also, update for anybody who has been watching the other streams, I found my thermo mug. So hopefully I will have warm coffee throughout this entire stream. Because it is morning for me and I need it. I don't know if you can see there is steam coming off here, which is a good sign. I mean, keeping it. Give me, I don't know if I can make an adjustment to my camera. It is a little bit dark. There we go. That's blinding, but hopefully a little bit better so you can see me a bit better. Okay, right. So, what I have just recently added is, if you remember at the end of the last stream, let me get zoomed in. I think that's probably fine. That should be okay. If you remember at the end of my last stream, we had an issue where if I would save the code, we would, anytime it would recompile, this would just sort of load. I'd have to close it and open it again. So what I've just done now is added an onEnable group function here with checking if the current window that we're running, so this is in our code graph editor window class, if the current window that we have here is, I'm just going to close, the current window we have here is still sort of serialized into the editor, then just draw it, because weirdly, when it's something to do with UIToolkit or just editor windows and how they work, they flush their drawing between compile times, I guess to recompile, but the serialized part of it stays maintained. And so that's why we were ending up with a null sort of window between writing code. So just a quick onEnable draw graph will allow it to load the existing one if there is one that's inside of the been loaded, basically. I've also added, because I spoke about this, I think last time we were here, if there is a code graph asset, I've also added a feature where you can, oh, hello Cube, we're going to make you move today, hopefully. You can double click and it will open the asset. So if you didn't know how to do that, there is a, so it's code graph editor, code graph asset editor, there we go. And in here, we have an onOpenAsset tag, which is called from the Unity editor callbacks. And that then runs this bool function, and basically it allows you to double click things and create behavior when you double click an asset in the inspector, in the project window. And so for me, I just want to load that asset, check if it's of this type, and open the code graph for that asset on a double click. So now we can click the open button, or we can just double click and it will open that thing in the right window for us. It's a really useful thing. And it's probably something I will include in another tips you probably didn't know about, because I realized I don't think I spoke about it there, but it's actually a really useful editor tip. So, okay, now we can delete. Did I add functionality for deleting nodes? I don't think I did. I think, no. Okay, so that's probably the next step we want to do today to just get started, is add support for deleting nodes out of our code graph asset. So let's go ahead and do that. So what we want to do is in our code graph window view, code graph view. Code graph, this is me after 2 weeks trying to remember anything I wrote, which is why comments are good, folks. Or I should have just watched the last video. But anyway, right, so the GraphView API has a callback for elements getting deleted and you handling that. So what we should do, this is where I need to open up my reference. So I'm going to do that on the other screen, so I have a constant reference to what we do. To be honest, I might just do mesh graph editor. Graph. Is that the view? No, that's just the graph view, which is where most of the behavior lives. Okay, that's already opening on the other. Ooh. Yeah, so we're gonna build in connections today. We're gonna build in ports. We're gonna build in drawing properties for nodes too. There's a lot of like there's still some boilerplate stuff we need to do, but it will rapidly build us into getting flow. But ideally by the end of this, I'll probably keep streaming until we get to the flow stage and we can actually see something happening on screen in our graph, and we have a runtime component. Because if you remember, I'm pretty sure I saved my drawing. Might not have done. See if I save it. Yes, I did. Okay, cool. So if you remember, this is where this is our sort of my very loose design into getting this thing to work. And essentially we have the graph component, which is a view model of the node data, which is just a list of nodes. And then we have a runtime controller to basically execute that data. And so we need to build that runtime controller, but we still need to do some stuff to fill out the data fully so that the runtime controller can understand what to do. And then we do some other things using attributes to make the editor graph functional. So we still got a little bit to go, but we will get there. Right. So it's on graph view changed, and we subscribe to it. I think just. Graph view changed. Yeah. Okay. Cool. So down here we just go graph view changed, and then we go plus equals on graph view changed event. And if you didn't know, you hit Control period on Visual Studio, you get a sort of insight into automatically importing things and doing methods and stuff. I love this so much. And so you can just generate that event with very little effort. So now we have our graph view changed event, and then in here we're gonna do a gonna check for whether it was a node that was deleted. So we need to do if graph view change dot elements to remove doesn't equal null. Oh, and then I think we have to return the graph view change. Cool. And then we make a list of graph view node. Editor node. No, what did I call them? They'll be up here. Code graph. Code graph editor node. Nodes. And I think we can. Actually, I don't think we even need to do that. I think what we can do is for each. No, wow, we want to go backwards through it so that we're destroying them in order that make. Okay, we can do that, and then we can do graph view change dot elements to remove dot of type. There we go. It uses link. Code graph editor node. And then let's just test this. Oh, to list. There we go. And then let's just test this is debug.log nodes removed, and then nodes count. And if it throws an error, then it doesn't work. Basically, oops. Let's go. Unity doing its recompiling thing. Taking forever. Only does. Back, buddy. Alright, there we go. Okay. So should now. Okay, cool. That has detected that we deleted a node. And then we just need to remove the node from our graph fully. So let's add, let's do it backwards just for safety. Let's do for int I equals nodes dot count -1 equal to 0. Oops, what am I doing? Putting friggin' commas. Minus, then remove node. Pass nodes into the thing, and then we'll make a method for it. And I think it's just as simple as we should record it. Oh, it's backwards just for like in case anything else is relying on it. And if there's like nodes that are talking, if it's talking to another thing, it's just, it doesn't really matter. But just usually when you're removing things, you want to iterate through the list backwards. But I don't know, it doesn't really matter in this. It probably won't be an issue. It's just kind of practice. There's no specific reason, but it might cause problems in the future. We'll find out. Okay, so let's make a record of that. So in case we want to undo, target object, and then just remove node. It is dev habit. It is purely dev habit. Yeah. You run into more mistakes trying to remove things forwards than you do backwards. So it's just kind of safer in general to assume that you're going to run into problems. Okay, so code graph. What is mcode graph dot node? Can I just do that? Yeah, we can. Okay, cool. Dot remove, and then I'm just gonna call this editor node. I'm gonna rename this so it's easier. Editor node, and then I think we can just do editor node not data. No. Are we not saving the node on the node? Graph node. Oh, we are. We're just not giving access to it. Okay. So we open that up, and we get access to it, so that we can delete it. Boom. All right. Let's remove it from the dictionary. I'm just going node dictionary dot remove. No editor node dot id, and then graph nodes dot remove. That's our list of our local nodes. We'll remove our editor node there. This is our node in our graph. Remember, there's two components here. There's like the data source, and then there's the view. So we have to sort all of that out, and then we update the serialized object. Again, just habit. I've run into issues with this, and sometimes updating it Unity's weird with when it passes serialized objects. And then because we're handling it ourselves, I think we have to delete it. We might not have to. Let me see. We might not have to, but we might have to. In the parent function, otherwise if you delete 3 nodes in one operation and do an undo. Yeah, that's probably a good idea. That's a good shout. Let's throw that up. Above into here. Just do if nodes dot count to the 0. To be honest, we can throw all of that in there. Cool. It doesn't really matter, but like if you did want to like restore one of them at a time, you could add a undo for that too. Really depends. But yeah, the way in which we're sort of restoring this thing will be interesting anyway, so we'll get to that later. Okay, right. So that should now have tracked our deletes. So if we delete our start and our debug, we now only have 2 nodes in here. Cool. And then if we close graph and we open it again, they are where they were, which is awesome. If you want to, yeah, I guess we can. I mean, it's like it's a constant back and forth. Sometimes you want to record edges. I kind of want to record specifically what's being removed. And it's like you could do a full remove, but we'll see. If it becomes an issue, then yeah, we'll just move it. It's fine for now. Season to taste, I suppose. You know, mileage may vary. it depends what you want the functionality to be. I'm fine with it just being like on a per thing because I want to be able to support also removing, like you might want to delete a connection and that get tracked independently. But yeah, maybe there's a full one. Maybe we can put it up there so then at least it's not on added, whatever. Removed stuff from graph. There you go. It's fine. Whatever. You can do what you want with it. All right. So let's go from there. I think we've got the basic stuff set up for now. And then what we want to do is, oh, wait, we're not saving the new positions. We need to do that first. That's why those just got reset. Good catch, compiler. Okay, we need to do, while we're here, if graph view change dot elements moved elements, my bad, null, does not equal null even, then we need to record that as moved elements. Boop, and then for each, I think we're just going to do a for each here. Code graph edit. We're probably somewhere in the future going to move this into an interface. I'm not going to do it yet because there's like a whole thing about teaching this where if I jump too far ahead, it gets confusing. But we will probably end up refactoring this into interfaces because there will be more things than just this one node that we want to manage. And so using an interface will just make things a lot easier. But we'll worry about that probably in the next stream. If we do one, it really depends. At the end of this, let me know if you want to see more, and if you think there's further we can go with things. But we'll decide that over time. Okay, so we do code graph editor node, editor node in, and then we can just do graph view change. I mean, you could do this down below as well, really. For moved elements, it's not, you don't need to iterate backwards, so it's less of a concern here. You know, because we're not deleting anything, we're just updating the data. So in that instance, we can just do, I think we can just call editor node, oops, dot save position. I don't have a save position. Well, we need to add a save position. Okay, save position, boop, do that. And that's now in here. Freaking internal. Make this, like, I hate internal. I blame Unity. And all of Unity's code base is marked as internal. It becomes I ranted about this in my my relatively recent spline tool video, and internal is the bane of my existence. Trying to code anything in Unity and extending anything in Unity. If you know, you know. Okay, so I think we can just do mGraphNode.setPosition, and then I think it's just this dot position. That's not what get position, maybe. What we want is, yeah, just called get position. Okay, which is part of the visual element, node element, and that should now allow us to store the positions on our object. So if we save this and then fuck around with things, so these all should reset, and then we'll move around, and then we're like most of the way there. I move those, and then I close this, open it again. Good. Okay, cool. What we also probably want to do is mark the asset as dirty when any of these changes have been made, just so that Unity knows how to serialize them. I I think that's probably the next best thing to do. Let me just... Probably. Maybe it's fine. Maybe it's fine. I don't know. I might do that. Anytime these changes have been made, it is kind of a good idea to mark the asset as dirty so that it gets saved. But I don't know. I'd have to close Unity and open it again. I really don't want to do that right now. So just maybe let's just do it just for safety reasons. Okay, so if something has changed, let's just create a mark dirty method. Wait. Do I do it as... Maybe I do it in the window. There is a there is support in the window for... Okay, let me have a look. If I remember, there's a function call. Oops. Inside of Windows, inside the window class that supports saving, has unsaved changes. There we go. Okay, cool. So all we have to do actually is flag this as has unsaved changes, and then we have to like say what to do when it's saved. There's also a save method as well, if I remember. Save changes method. Yeah, okay. So let's do I wonder if we can do m_current view. No, let's handle it. Well, let's try this and see what happens. Work for serialized graph elements. Graph view change. Let's add a graph view changed event on change. Let's do that, and then just return the graph view change. Because like we know something has changed, but then I think we can just do this dot has unsaved changes equals true. And then override on save changes. Can just do let me do this dot. I'm completely winging this. I remember doing some of this before. It's just been a long time. Yeah, because the window is technically a set. Is onsave changes part of the editor window, or is that just part of a script? Yeah, it is an editor window. Okay, so onsave. All right, let me just check that we can do that. I think what we can do is we can mark the script object as dirty and then call save anyway. Okay, but that should flag the editor as dirty. We could maybe do that in the graph view change so that when it saves, it just... Yeah, there we go. Okay, cool. So we made a change. It's flagged as dirty, and then we hit save, and it doesn't do anything. We don't even get a message. That's interesting. Why is that? Well, that's odd. Okay. Hasn't save changes equals true. Performs a save action on the contents of the window. Oh, that's just like, you can just call it. Oh, interesting. All right. Well, then we don't need that. We can just do editor utility dot set dirty, I believe, and then just mark the object as dirty, which would be I think we mCurrent. Don't want it to be this. Maybe it would mCurrent graph. Yeah, that's fine. That should be fine. I just can't remember how to resolve the window being flagged as dirty. There's like an on save thing. There is another method here. I'm sure there is. Is there a save change event callback? Maybe there's a. Prompted to save. I think it's just so that when you close the window, you can get the save changes method. I think I just have to flag it. Yeah, you get a save. Okay, which is what you want. You kind of want to be able to detect that there's unsaved changes. So that is important, which is part of what I'm doing. I think I'm just misremembering exactly the way that I wanted to do this. Give me one moment. There's a step I'm missing, and I cannot remember what it is because Unity codebase is like this. You can like make a button and then call save changes or discard changes, and that flags everything. But I can't remember how to hook into save. Control S. Oh, you know what we could do, actually? Which shouldn't matter, because if we flag that as dirty when you hit Control S, that's probably what I needed to do. Okay, so just on GUI, yeah, it's probably just if and current graph doesn't equal null. That's probably what we need to do. Which is that. There we go. Okay, so we need to do, and then okay, if can you check if thing is dirty? There we go. Current graph, then set that. There we go. Else this dot has unsaved changes equals false. I think that's what we need to do. So that should show us that, and then if I hit Control S, there we go. Cool, that's what I wanted to do. Just so we know that it's dirty, so that if we haven't saved, we close tab, we get our message, and then we can give the unsaved changes message and go from there. So that's perfect. That's exactly what we needed. Okay, cool. That's all I wanted. So now I'm aware that I've moved things around. I haven't hit Control S, and that asset hasn't been saved. So that's great. So that should keep things in sync. We can then probably do functions to like update things, but that's all we need to do for now. Excellent. Right. So the next step is to start. I think we just want to start the flow and expose some properties on nodes. We've got our basic behaviors. We need to deal with connections, but we have to do that after we've got ports. So it makes sense to draw out the connections and then go from there, I think. So yeah, let's do that. Okay, so what we want to do is grab the we need to make some ports for our start node. We need to define ports for our just trying to figure out which way I want to do this. Let's go with just being able to make flow ports appear. I think that's probably the best step. Start node only needs one because that's where it's going to start. We could also make the background green. That will be some nice touches I think we do after the fact. I think we'll just stick to working on the flow first for now. Let's not put the cart before the horse. Okay, so We need our attribute. Okay, so I think it's implied that in this situation, if there is a node, the node info could define what flow ports it. Well, no, because we might want some that have none. So maybe we manually determine, or we just set it to false. Like has flow port. Yeah. Yeah, okay. So I think we have two Booleans inside of the node tag. So if you don't remember, in the node, we have a node info. And that essentially tells how to draw our graph and like what we're going to draw. So inside of here, we have some attribute information. And so what I think I'm going to do is add in a Boolean for input, flow input. Let's be verbose. Has flow input and bool has flow output, and default those both to true. And then we'll have a has flow input and has flow output. Just for those questioning things, I tend to try to lean towards a more verbose, this might just come from me working in a team regularly, or just general practice I picked up along the way. I do tend to operate on more verbose programming practices so that you can at a glance clearly see how flow is moving. So, you know, I'm not always going to lean into ternary operators or like returning things, because sometimes it's easier to put sort of if-else statements in, or it's easier to put like longer, more verbose function and method names. And so, you know, your mileage may vary depending on your projects and stuff, but that's just sort of how I've learned to build things together. I also tend to just do the thing that comes immediately to mind first, and then I'll go back and sometimes clean things up afterwards. And then there's the other caveat of like when I'm doing things for a tutorial, I want to try and be as verbose as possible so that you can see what I'm doing. And so it might not be the most optimal way to do anything, and that's fine. I mean, as long as the code works, that's all we really care about most of the time. But yeah, just so you're aware, if you are wondering that, that's sort of the way that I operate. So m has flow input equals flow input. I mean, you put a bunch of programmers in a room, they're all going to argue on the correct way to do something. And I mean, mine is always, does it do the thing that it's supposed to do on screen? If the answer is yes, and it's relatively performant, then who cares, you know? Unless there's really specific limitations that you need, but then again, that's part of the does it flow, like does it work? Does it do the thing it's supposed to do? As long as the answer is yes, nobody really cares how you got there. Again, unless it's significantly causing performance issues or whatever. But again, you try and worry about that when you come to it. Yeah, if it works and it runs fast enough, that's good enough. So yeah, right. So menu item is the like string that we use to determine where the node is going to appear in the menu. I showed how to do it in the last video, so feel free to go check that out if you want. But yeah, like I actually don't think I have it working yet, but it should be. Oh no, yeah, there it is. So debug log, process, start. They're split into their specific menu items, and so we can filter that search window. I cover it in the search window video on the channel. If you're curious how those search windows work. So let's go with that for now. That gives us the info we need. We need to be able to get that. So these should really be uppercase, but I kind of fluctuate between how I decide to do things. Sometimes I put an M in front, sometimes it's just an underscore. It really depends on my mood of the day. It's not great. When I'm working on my own stuff, that is. We tend to have more specific code practices, but again, as long as it's readable, nobody really cares that much. M node title. Nope, that's not what I want. That is not what I'm doing. Right, I want flow input. There we go. My coffee still hasn't kicked in yet, I guess. M underscore has flow input, and then public flow output. I should put a has in front of that, really. Score flow output. Has flow output. Flow input has flow output. Okay. Now we can make our first set of nodes. What we're going to do is go back to our editor node. Helps if I learn how to type. Oh, I'm just all over the place. Editor node. Nope. All right. Fine. What am I doing? What's going on? Code graph node. Code graph editor. There we go. Got there in the end. Okay. There's nothing in here yet. Wow. This class is really gonna go crazy, because you know this is the sort of dynamic class that we're building, let's go crazy and start putting things in here. So the first step is to, as part of our attribute, use the info. So we go if info, oops, dot has flow input, and we want create, we'll do create flow input port for now, because I kind of want to do some different things. And then we have if info dot has flow output, create flow output port. This also makes sure that these are the first ones that we make. We'll eventually probably style them. There's a lot of things you can do at this point. This is where it starts to become like different demands of the tool that you're building are going to want different visual styles and approaches to this. This specific graph that we're making today has a flow system. My mesh graph tool does not. I spoke about this in the last video. My mesh graph tool has a right to left mentality, the way that like shader graph does. And, you know, if I'm trying to make a cube, oh, this always freaking happens the first time I try and do something. There is a huge bug in this code, and I will fix it eventually. So we don't have a flow because the flow is determined from this. The method that we're calling actually gets the output method first and then says get the value from the mesh. That then talks to this thing. And let's say there's another, like maybe there's a merge node in here or something, and another cube. And so like it flows in this direction because we're going from this port and we're getting the value from that port, which gets the value from these two ports. It processes it and then sends it back, right? So it's like, it's a little tricky to get your head around, but that's how what I call a non-flow. I don't know. There's no real name for it, but like this doesn't have a flow. This just has like a setter and getter system where it's just like, okay, grab me this value. What's my connection? It's that one. Okay, then what's, you know, other connections needed? Okay, grab the info from that. So you're just like fetching the data, and it's sort of like a data-driven system. Whereas a flow-based approach, which you might want for AI behavior, or you may want for visual programming, which we're kind of just going to do here, it will need a flow because it needs to move in a direction. It needs to move, it needs to know where to go next to continue iterating that flow. So two very different approaches. And so this section only really kind of matters if you want flow. But yeah, hopefully that makes sense. So it's up to you. Like, that's a good way of putting it, Enrique. Like it's either a state machine or there's no state, and it's up to you if you want to have a state. In this instance, we're building a graph that is going to have a state because I think it's worth showing. You know, you're going to get more out of this tutorial if I show you how to make a state, but you don't strictly need to have a state. So, yeah, that's that. That's my explainer over. Let's carry on. Okay. So I actually don't have this bit of code in my mesh graph, so my reference is kind of useless at this point. And I don't really want to open up my other project on stream because that's my work project. So let's just wing it and figure out if I know enough about this project. I'm working in GraphView API to get there. Let's find out. So what we need to do is create a port. We need to create a list of ports on our node. So what we probably want to do is create a list of ports. We should also save the output port so that we just know it all the time and we can just get that direction. So let's make we're never really going to want more than one. So that should also be fine. So let's create a port that we're going to call, oh no, let's not make it public. That should be private. So we need to, let's do this. We need to go m_output port. And we also are going to make a list of ports. That will come to be important later. m_ports. We should instantiate port list. Instantiate. In our constructor, construct our ports. That's probably a better way to do that, to say that. And then let's start with the output. We'll worry about the import in a minute. Actually, our input port, does it matter that we keep track of our... Don't think it does. We'll worry about that if we need it. If we need it, we'll add it. Okay, so m_output port equals... I have a method for this. Might be that built in? That is built in. Yeah. Okay. So instantiate port, that is built in, and then an important decision. Do we want the graph to flow horizontally or vertically? I think in this instance we'll just stick to the standard horizontal. For behavior trees and stuff, I tend to use a vertical. If you and VFX graph also uses a vertical flow, and that allows you to sort of chain things. I like vertical flows because you're then not scrolling left and right. You're just kind of scrolling down and reading things in a way that you normally would. But for a specific flow, and you can have like lots of different flow diagrams and they're all moving downwards. I quite like that as a flow method. But for this instance, we'll just stick to what everybody knows. We'll go direction. This is an output port, and capacity can go one place for an output port. And the type. Right. So now we get to defining types. Will this one have the ability for nodes to have multiple input and output ports? Yes, we will do that when we start working with the properties, and we want to have, you know, properties go to multiple places like that. Outputs, I'll allow that, but I think for flow, you kind of don't want to be able to flow to two places. Well, maybe. I don't know. Let's not overcomplicate it. We'll stick to one. Flow can only go to one place. In theory, you could split flow into multiple executions. It's just probably going to be difficult to work with at that point. So let's not make this more complicated than it needs to be for the meantime. For the type, let's create our types. Now, I like making a list of like types that we're going to support. And for instance, this should be a flow type, right? So you know that it's that type of port. So we have to kind of go and make a bunch of port types. So let me just try and remember how I want. You can also, we could just keep them. We could just keep them to Unity types. I don't know. I don't know what the best way to do this is. I don't know if I have them in this example. I don't think I use them. In some examples, I strictly combine like types because of concept. You know, like this is a character. This can feed into another character port. So like they're typed by port and what I want the port to be able to support. So this should be a flow. So I think we do need to do that. Okay. So let's make a new class. And let's make a type. editor. I think we just call them port types. Yeah, we'll do that. And then go what's up? And public class flow port. Okay, and then we'll add other types as we want. We could maybe support just normal Unity types, because we want to pass vectors around to ports that can take vectors. So we might deal with that. If we're dealing with data types and stuff too in the future, we may want that. But for now, this is going to be type of port type flow port types dot. This basically just means that, like, can you connect X port to Y port? And we have to add support for that as well if we want to be able to do that. But this will just make sure that, you know, only flow ports can go into other flow ports. Okay, so let's then continue building node and adding it to the port and adding it to our node. So m_output port name equals out. Let's just call it out for now. And then p.tooltip, oops, output port dot tooltip is the flow output, and we'll just stick to that for now. And then we will add this to our port list. Add m_output port, and then we will add it to our output container, like so. We'll basically do the same thing for the input port. Just copy that. Name this. So this isn't going to have one yet. So we'll just call this input port. Do the same thing. Add the input port. Did I add input first? Because input should be the first. Yes, I did do output. So just to make this easier, just for me, I want it this way around so I can read them in the way that I expect them to flow. And then just do input. Flow input, I'm just going to call this flow out. There we go. Okay, that'll do. I think that'll do for now. I just friggin' renamed them the wrong way around because I'm an idiot. Why would I do that? I'm so silly. Okay, there we go. Up here. There we go. Right. Jesus. You can tell it's the end of the week. The flow input. Okay. Input port. Cool. All right. That should then, if we look at both of our things, we should now get them. Cool. Okay, it's in the wrong place. Right. Let's call this in. Put the input in the input container. That would make sense. Input container. There we go. But input needs to set as in. Input. Perfect. There we go. Okay. And then we need to add the logic for whether these ports can connect to one another. So do that. And then we can go from start to our debug. Let's make sure that the start node doesn't have an input port. Yeah, okay. So, well, this is just a script. Why is this a start node? There we go. Then we'll go has flow input false, has flow output true. Perfect. We can do some stuff eventually to make sure that, like, if there's nothing in here, we can clean up how these nodes look or whatever. For now, it's fine. I think we'll worry about styling and all these kind of things a little bit later. Oh, there you go. It sorted itself out. Okay, so lovely. Now we need to just be able to plug ourselves into the input node, and then we can work on the flow and start doing things. This is exciting. We're getting there. We're starting to resemble a graph. Total time, I guess, so far is 3-something hours. So if you want to build a graph, know that it will at least take you 3 hours. I mean, probably less, because you wouldn't be talking to the camera the entire time. But it's a long thing, and there's still a lot more to do. So, like I said, this has been a really difficult thing to figure out how to present. But there's so much here, and it's just so underdocumented that I really wanted to at least give people a starting point. So I really hope this helps. And I hope this is giving you ideas of what you can do. I'm really excited. Unity are also working on a new thing called Graph Tool Foundation, and that will eventually replace this. And I think when that happens, I might talk about it in a full video, because that'll be the future. So just be aware that this is an experimental API. But I mean, it's been experimental. I've been using this tool for like 5 years now. So, yeah. Right, so next step then is to determine what can be plugged into where. I'm glad this helps. Thank you. Cool. Right. So, I can't quite remember what I need to do to allow you to plug things into things. There's a place somewhere. I think you have to do it in the graph. I think it's a callback in the graph view itself that determines what can be plugged into what. Get compatible ports. That's the tip. Okay. So, so in here we have to, I think it's just an override. Yeah, okay. So public override get compatible ports. So this is basically the bit where it's kind of funky, but like you get to determine what can be plugged into what. It's cool. Excuse me, but it's annoying that it's boilerplate. I really hope that when they do change everything over, that they really fix how complicated some of this stuff is. And I get it, right? Like, it's experimental. It's supposed to be used internally by the teams. It's annoying because it's a lot of really powerful tools. But yeah, it just, like, it's one of the parts of Unity that shows that if they were doing this full time, and actually making things with it, it would probably expose all this stuff. I mean, it's exposed. I don't know. I have mixed feelings about it. It's one of those like dog fooding situations. Unity constantly feels like they're not actually, like, they just half-baked tool. I think everybody who's worked in Unity for longer than like 2 years understands this. And it's painful. Yeah, there's so much boilerplate, and it's frustrating. But you know, we work around it, we deal with it, and sometimes that's part of the problem. Okay. So we need to in all. Right. Oh, right, because every time you click a port, it tries to evaluate every node in the graph to look over which port it is able to be plugged into. Yeah, okay. It should just kind of inherently know that stuff. So, all right. So that's what we have to do. We have to gather every node. Thankfully, unless you have a massive graph, this isn't too horrible. In the graph nodes. This is why we have a where we add everything to the ports. So we then make all ports dot add range node dot ports. So basically we get, oh, I don't think we've exposed it. Graph node, graph editor node. We have not exposed the ports. So we basically add its list of ports into a list, expose that to the graph, and then be like, here's all of my ports. What are you trying to plug into me? And then we handle it that way. So you don't have to if you want to make sure the stuff can't get plugged in, but then it's like, why the heck is that a port? So that's why, I did see somebody asking earlier, that is why we have the ports list. So here we can go node.ports and add that to the range. And then we just do our validation checks. So for each, and we return all of the valid ports. So, I apologize. I'm having a bad time typing today. So for each port P in all ports, then we validate them. So if P equals start port, then continue. If port dot P dot node P node, I think this is fine, equals start port dot node, and continue. Just kind of the same thing, but just to be sure. And then if the direction is different, start port dot direction equals E dot direction, then continue. And can't plug horizontal like input nodes into input nodes. And then if I think for now we'll just do if the port type matches, and not support any like cross compatible port types for the moment. I've switched those around, haven't I? That's really silly to have switched it halfway through. Let's clean that up. Yeah, I think this will be fine for now. Then ports.add. Cool. Okay, so we fail out basically, and then we validate that it's the same type. You could also do that and then just make sure that these aren't the thing, but whatever, right? It's fine. Either order. So that now should allow us to plug our output port into our input port. But it shouldn't allow us to plug our output port into our input port of the same node. Yeah, right. But we should now be able to do that, which we can. Cool. Awesome. Right. So we've got the first sort of flow set up. The problem is this is only visual. If I close this, if I save this, close it, and open it again, that has not been serialized. So we need to figure out how to do it. Let's save our connections. So we now need to build out a whole new struct with data as to what I'm connected to and where I'm going. So this is kind of the last piece before we can start doing some flow support. So we are nearly there. Just keep on moving on. So we need to make a new class. Code graph connection. This is just going to be a serializable class. Like so, and then we go public. Oh, we also need to make a new struct. Code graph connection port. And here, well, I mean, this could also be a struct. Yeah, I mean, it may as well. it could just be connection. I'm just going code graph connection because yeah. And then code graph connection port. Let's call this connection info. Wait, no, connection port. Yeah, that's good. And then we just go public string node ID and then public int port. Oops, int port index. And then if we want to build that, we go code graph connection port, and we go string ID int index. And then this dot node ID equals ID index. Do that, and then do the same thing here. We go public code graph connection port input port, so we can grab the specific one that we want, and our output port, and then we can feed those in. Port output, and we should also make it so that we can like so again, this is just so we can serialize those connections, so that when we load the graph we can reconnect them, and it's so our flow can understand where to go, right? So it can read the connections, and that's pretty much exactly what we do. We operate based on connections. So we fetch, like, am I connected to something? If so, get my data, or move to the thing I'm connected to. So this connection part is actually the core way in which we flow through our graph. So code graph connection, and then we'll just do a string input port ID int input index string output port ID int output port index, and then we can just make them ourselves, just so we have some flexibility over how to do that. So we'll do index, oops, and then we'll do output port ID equals, oops, no, output. God damn it. Output port, there we go. Code graph port, output port ID, and then output port. So, okay, cool. So then we need to grab a, we go to our asset and make a list of connections. Wait, I might put the connection in, I did, I put it in the editor. We should move it to runtime. Should change the namespace. Cool. And then now we should be able to get code graph connections here. There we go. And then we go m underscore connections. So public list code graph connection. And we go connections, and then we'll fetch those. All right. Perfect. M is equals new. Okay. So now let's discard those changes. Is this just gonna, yeah, right, because that's not what's value cannot be null. Huh. All right, I don't know what's happened there, but sure. I miss. style sheet. What does that have to do with anything? Unity, why are you being weird? Okay, well, let's just delete this and we'll make a new one. And see if that fixes it. There we go. Okay. Cool. Right. Start. We'll add our debug. Okay. So save that. And now we need to edit our connection method, our graph change method, to support making connections. So what we're going to want is our connection to get added as we make those changes, right? And then we also want to be able to load them. So let's go back into our view. This is our graph. And we want to do a couple of things. So we want to kind of have a dictionary of connections so we can look them up more easily, but we might do that later. It's not super important right now. And we want to do callbacks on, want to hook into the callback of them getting created and set them up. So let's, I think it's just edges. I think it uses the edge system. Yeah, and create edge. Okay, so open up our GraphViewChanged method. And then we need to create a new if GraphViewChange dot edges to create doesn't equal null. Then for each edge, we can make a new method called create edge. So we'll grab each edge and then we'll build a connection from those edges. Because the edge basically has all the same information we just made. We just need to serialize it. So it really is just a case of, so we'll do the same thing we did and added connections. We need to go in here as well and check if any of the things that we've removed are connections and remove those too. But part of the remove node process could pay attention to that, but like we'll deal with that in a minute. So create edge, and then in here we want to get the node. So it's going to be a graph editor node, input node, and then that'll be edge dot input dot node, I think. And then we just have to cast to it because we know that it's going to be that because that's currently the only thing that exists. Like that. And we'll do the same for the output node. And then I think we find the index of the port and that will give us what we want. So int input index equals input node dot ports dot index of edge, I think, dot input because we need the port, right? There we go. That, and then int output index equals output node dot ports dot index of edge dot output. So let me just make sure that's the right way around. Input, output. Yeah, cool. Doesn't really matter how you do this. You just have to, you know, do it. So I think we can then just feed that in. So we can do mesh. We can do cograph connection. Connection equals new cograph connection, and then we do input node dot id node. Oops. Dot id. And then we'll do input index, and then we do output dot node ID. So we're getting the GUID from the actual data source and saving that, and then the index of the connection. And then we're going to do the same thing for the output as well. Output index. So again, that's why we add them to the list, so we can get the actual connection information. And then we will add that to our graph. Code graph, m_code graph dot connections dot add our connection. And then that should be it for now. What we now need to do is check that that worked. So let's go in here. That now should have made a connection for us. It has, but connections aren't serializable, so we can't see them. So let's fix that. That should now allow us to view them. There we go. Okay, and this is a good example where it hasn't loaded that now, right? So we now want that to load that connection back. But, our node ID. Wait, are we not assigning GUIDs to our nodes? Haha. I might have missed. No, we are. Okay, GUIDs there. Oh, sweet. Maybe I'm using the wrong method there. And okay, let's delete that connection. So ID, because the index, was the index correct? Wait, let me see. Oh, no, okay, so something there isn't working. All right, let's deal with that. Oh, wait, no, that would be 0 and 0. That is correct. It's 0 and 0. All right, let me try a log node into another log node, because that should be 1 and 0 then. If that's correct, then the indexes are right, at least. Yeah, okay. Okay, and our output port is that. Oh, no, there you go. Oh, we got them this time. Oh, weird. Okay. Fair enough. It didn't work the first time. Now it did. All right. Maybe because they weren't serialized the first time. Probably. That's probably why. Cool. Okay. Well, there we go. Okay, cool. That all works. Good. Be sure to serialize things, kids. Okay, so we'll close this. Discard that. Start again and connect this one up. Let's delete that. Save this, and we're getting errors. Cool. Because the property has disappeared. This will happen. I hate trying to fix this. I'll worry about it in a minute. Let's close that for now. Oh, now what? Oh. It's because we're in debug mode. That's why that happens. There we go. Okay. So we should have a connection saved. Oops. Double check. Okay, so now we need to load that connection, right? So that our connections persist. And so the key there is to use our load method to redraw and reconnect them to the nodes. So that's what we do now. So once all the ports have been added to the graph, we want to load, draw our connections. So we need to make a draw connections method and just pop them back in. So here we'll go draw connections. It's also worth noting that the graph view change event should go after this. Otherwise, when it's drawing them, it will trigger the graph view change event. So when it's like loading, it will trigger the event, and then like you'll get infinite nodes getting added. So make sure that you add this callback after you're loading the nodes the first time and loading the connections the first time, because you don't want that weird infinite callback loop. So let's bring this down to the draw nodes area so they're together at least. Try and do some organization in this class. And then we basically just have to check if the connections are null. So if _code graph.connections equal null, then return. And then if not, for each code graph connection in graph.connections, then I think we just create a method called draw connection that, make that method, and Then we, oh, okay, we now have to do some fun stuff of like how we fetch these nodes. Okay, so we need to get the input node and the output node. So we need code graph editor node, input node, and code graph editor node, output node. And then we need to, so what we can do, let's create a method called get node. Oh, do we have it? Did we do it already? Get node by GUID? No, because that's a graph thing and it's different. Get a node with given GUID. I think that's different. I think that's a different call. Go into graph. I don't think that's something that I've made. No. Okay. Let's just call get node because we have a whole system for this. Get node, and then we want to do input node dot connection dot input port input port dot node ID. Okay, and then we'll do the same. Get node connection dot output port dot node ID, and then make that method. And go through our dictionary and see if we can get the node. So let's do code graph editor node equals null, and then we go node dictionary dot try get value. Just do that, and then we'll get the value of the node ID, and then we'll set node to that if that's true, and then we'll return the node. So we either get the node we want, or we get a value, or we get a null node. And so we do that. We'll put some. We can put error checking in. So I'm not going to do it right now because it's just. We'll put a little. Okay, we'll do the first step of it. But I won't do a huge amount of error checking because you can like clean up connections if there's like null data in there or whatever, but you don't want to see me do that. So we'll just check if it's null so it doesn't fully break, and then just return out of this. So we just don't draw a connection if we have a null node for whatever reason. But then other than that, then we need to get our connection. So we need to grab the ports from each of the nodes and then build an edge that way. So I think you can just connect to them. Right, so let's grab our input port and port. And we'll do these at the same time. Okay, so input port, we'll do input node dot ports, and then we can do connection dot input port dot port index, and we do the same for our output port. So we do output node ports. We should check to see if the if the connection ports have changed or whatever, but you know, it's neither here nor there really right now. We shouldn't have any issues for the moment. Check. And then edge equals import dot connect to output port. And then we add the element to our graph, which like happens automatically when you interact with it, but we need to do it dynamically here. And then like we could dynamically add connections, I guess. We could make a connections dictionary. I don't think we'll need that right now. We will need to handle removing connections though. So that's like the next thing we'll do, and we might need to do it as part of that so we can look them up easily. Honestly, that might be the best way to do it. But there we go. As you can see, that has caused our connection to load. So we did it. Hooray. Cool. So now if we make another one, I make another node and connect that up, and then save, and then close our graph, and then open our graph, we have supported connections being added and loaded. So that is a huge chunk of work that we've cleared through just now. So yeah, final thing is we just want to add support for this connection data getting removed when you hit delete. So that's like the last step, and then we should be able to move on to functionality. So let's do that. So I think we probably do want to make a dictionary so that when it gets deleted, we can check the edge. Because we want to link the edges to the connection so that we can just be like, because all we'll get back when we delete it is the edge. Whereas we need to delete the actual connection data. So let's do that. So let's do public dictionary. We'll make the edge the key, and then we'll make the connection code graph. We may need to turn the connection into, maybe it should be fine as a struct. We may need to make that specifically a class. So it can reference itself specifically. Edge connection dictionary. And then we'll make that a thing. And then we'll add the edge to the dictionary with the connection intact when we draw the connection. So we go connection dictionary, add edge and connection, which is just like that. That's now in our dictionary so that we can remove. So I think it's just remove edge. So let's just make a remove edge. Private void on remove. No, we got remove node. So let's just call it remove connection from an edge. And then connections dictionary, which we'll do. But we basically need to look so at the if try get value out code graph connection then m underscore nodes code graph connections dot remove that connection, and then remove this from the dictionary. That should be all we need to do. I think, let me just double check. Yeah, we just sort of, yeah. And then we just need to add that into our graph view change event. I think that's all we need to do. We'll find out in a minute. Is it part of edges to remove, or is it part of the elements to remove? I think it's part of elements to remove. Yeah, for each edge. Okay, so for each edge, I'm not going to bother going backwards this time. In graph view change dot elements to remove dot of type edge. Then we just call remove connection e, and that should do what we need it to do. I think. I'm pretty hopeful that that is what we need. I won't have it in debug mode while I look, but hopefully if I delete these, that should have cleared up our, yeah, there we go. Great. Awesome. So we now have our connections set up. And I think the last thing we want to do now is add support to drawing properties into our, well, maybe we set up runtime first. And then we can, yeah, okay. It's probably more important that I show how to set up runtime and then do properties. And then I think we'll be done for this. So, and then I think in the next stream, we'll show how to do like other property nodes. So we'll expose some properties in the graph, I think. Maybe do that. That might be the best thing to do. Yeah, all right. So what we have then is our debug log node and our start node. So let's do flow first, because I think it's important that we just get something going, and we can just by default have something run once we hit the debug log node, and then we can put some properties in to expose it. I think that's the best flow for this. So, all right, this is our connection. So we'll just hello world. So now inside of our nodes, these are like our actual node nodes. What we want to do, graph asset as our base. We want a virtual class, a virtual method. Do we go virtual or do we abstract? Let's go virtual. And then we call on, let's just call it process. It's like when we want to process the node. And we also want to return a string, which is like the next node. Do we return? Maybe we just return a node. And another code graph node. How do we want to move through this? Our connection. There's different ways we can move through the, like, process the runtime. It's going to depend on the way you want to do things. I'm going to do it this way because this is the way that I'm kind of used to, but there's probably more like cleaner ways to do things. So let's do that. And then we will return string.empty for now. Right, and so basically, yeah, because then if we have a branch, we need to determine, okay, and then we can just move through nodes that way, right? So let me break down the runtime a little bit to make it kind of clearer. So should I extend this out? Maybe. No, I'll just make a new drawing. Okay, so basically what we do is we'll start on our node, on whatever start node we have, and our runtime will ultimately just call a loop that is like, well, I wouldn't even call a loop. It's kind of straightforward in just like process node, and it will expect a string back, and if that has an ID attached, we try and find that node and then just process that. So it is pretty straightforward, I guess. So it's just like the next node to move to comes from this process node call, and if it isn't empty, we just move to it. And then that gets called on this node, and so on and so forth. And then like that determines how we move through the graph. This is a terrible drawing, but hopefully that makes sense. So the actual runtime is just calling process node on every node. And so this is kind of self-contained. I need to make this not fill. It's clearer. So it's like, the little runtime method we execute is ultimately just going to do a call stack until it doesn't get a node back. Send this to... clean this up a tiny bit. Yeah, so if it gets a node back, it just goes to that node. And then if it gets another node back, it just goes to that node until it doesn't get a node back anymore. And that's kind of it. That's all it needs to do. Because then each of the other nodes can handle, if there's other data we want to pass around, each of the additional nodes can handle that themselves. But for like the runtime, we just have to move through the flow ultimately. And so we call our process to execute. You could call it execute, whatever you wanted to call it. But yeah, that's essentially how it works. So that's what we'll do. So what we want to do is, because we want these graphs to run on an object, and, you know, this is different, right? So it's going to depend on how you want to do it. So for my mesh graph tool, I have mesh graphs on objects because I want to spawn meshes that way, right? So in this one that I showed a minute ago when I was putting it together, I want to be able to create meshes, and it creates a renderer as part of the execution. This is the runtime script. And so it will just sort of handle that. Material, there we go. And I can do it that way. Well, let's go with element. Is that going to work? And this essentially is a very simple script that just has its own graph as part of itself. And then this is the asset basically that we're currently working on with everything in. But when it runs, it just calculates the mesh, and that's basically what I'm calling the process. Again, because this is data driven, it's not, there's no state. It doesn't need to do the same sort of things that we're going to need to do, but it just calls the first node and then calls a get value method, which is the same kind of thing. Each of these nodes have a get value method on them. And that then returns what it needs to return so it can move through the graph. It just goes through things and tries to return a value, which is eventually should end up being a mesh that the graph can draw. And so it starts at the end node on the output node, calls get value from this port, ends up here. Then this calls get value from these two ports and does this, and then merges and then processes. So we should look at the merge node because that kind of helps explain what I'm talking about. See this get value method. So this is what our process method would do, and it returns an object because my mesh node, my mesh graph tool doesn't really know what it's going to get, and so because it's expecting data, not specifically a node to move to, and so it does that. It processes a thing and then returns the mesh, and that's what we wanted in the end. So then it draws the thing that it needs. So it's a little bit different, but hopefully that gives a little bit of a basis of how we're going to move through things. I think it'll be clearer when we're implementing it. But so the back in our tool, our code graph tool, which I can move down here now, I think. What we want to do is we want to just get hello world to appear. So we need to make a execution script, I suppose, for these graphs. So in the runtime, let's create a script called is it recursion? Yeah, it's basically recursion. I guess you could consider it recursion. Code graph. I don't want to call it code graph runtime. That makes sense if it's like grouped a whole bunch of them together. But because I want this to be an maybe just an object. Code graph. I think code graph object works because we know then it's kind of a game object as well. That kind of helps cover that up. So let's call it a code graph object. And let's go to our good friend noun project and make a nice little element for it. Noun project. And let's just go with a cube, I think. What do I like? Let's have a look. Pretty cool. That's cool. Oh, that's nice because it sort of shows some directionality to it. Oh, that could work. I don't know why that's showing up in cube icon. Let's go with if I click this, I wonder if I'll get some variations. Any of these? Let's go with that one. I don't know. That's kind of cool. Yeah, I like that. All right. Download PNG. Thank you, Angara Putra, for your icon. Okay. And then let's just add this into I think I put it in the icons there. Set. Okay. The GUI. Then set photograph object to 1. Oop. And then file. And put the code graph object on our object. Hooray. Okay. Now let's open this up. Now we need to take a code graph. So code graph asset. M graph asset. Serialized fields. And then we should go. So I think what we do is we just do it on enable and we just execute the asset. So we do just make an execute set. We clone it. Let's clone it. So in case we accidentally fudge around with it. I think you can just call instantiate on a scriptable object, and that will make a copy at runtime. And so we now aren't actually editing the project version if we make any changes to it. And then we can just call, we can get our nodes. So we do code graph asset, dot. Let's just call get start node. It should be the first one, but let's make sure that we get a start node. We could find the start node. We'll get it from the asset. Yeah, the asset can return it for us. That's fine. So we can do code node, start node, get start node, graph node. Oops, why am I doing that? Not void public. There, and then we go through our nodes and we just go nodes dot, we can just do of type start node, and then there shouldn't be more than one, but I'm just going to do this because it's easier. We could just return the first, but like, let's just do this. So, we should do a check. So we'll also do if start nodes dot count length is equals 0, return null, but then also throw an error. Log error. There is no start node. So what we probably could do is force the start node to A, not be deletable, and then also always be added the first time. Maybe that's not such a bad idea, but we'll worry about that in a minute. Let's focus on getting this going. Okay, so we can fetch the start node now, and then we just do start node dot on process. Is that what we set it to be? Yeah, on process. So we do string next node equals start node on process. And what we're actually going to do here is make a method called move process and move to next node. And we'll feed in the start node. And in there, do that. And in here, we'll do if string dot is null or empty next node, then we can just do nothing. Wait, no, if string is not next to non-empty, then should get the next node. So code graph node do. There's probably more elegant ways to do this, but this is just how I like to do it. We'll just call it get node function, and then we'll pass in next node. Let's rename this to next node ID. Like the node itself could return the node it's connected to. We could skip over some of this stuff, but this gives us a little bit more flexibility for sort of supporting things in the future. So we'll do this. We'll just do it this way for now. Again, there's so many things, so many ways you could approach doing this kind of stuff. So please don't take any of this as gospel or anything. It's really just meant to be a starting point. Process and move to next node. So this will now basically iterate over the process method on any node that it passes through until it doesn't get one and doesn't get an ID back. And so then what we can do in our get node is we can I think this is returning. Yeah, this should be returning a. Oh no, that's a get node. Okay, so public get node. We'll go back and look at our graph node in a minute. Let's just solve this. Don't forget about it. Why don't we make ourselves easier and create a method called init, in which we make a dictionary that's not serialized in our asset, and just has every node ID and every code graph node. Don't serialize this because we want it to happen at runtime, and then we make our dictionary when we first boot up our graph or runtime, in which case we go, so go for each code graph node in nodes, and then we just add it to the dictionary. Node.id and then the node. And then here we just if m underscore node dictionary dot try get value next node ID out node, and we can return node or return null. And that should allow us to just very quickly fetch it. So we just need to call in our runtime object. We should make sure that we init the graph asset. So actually, let's do m underscore graph asset dot init. And then, oh, but I don't want a reference to that one. So let's rename this graph instance, so it doesn't get confused like that. Oh, ooh, yeah. Oh, shoot. Okay. Let's make a reference to our instance. There we go. Okay. Let's do that then. Execute asset, then we don't need this. And we can do it that way around. There we go. Okay. So that should just handle all of our flow now automatically. We just need to finish off how we can move between them, move between our connections. But we can test our start node. So let's just, before we move, let's just test our start node. So let's do override process, because we're going to we run that on our thing. We just return nothing. But let's just do another debug.log, and we'll just call this hello world to see if we are calling the process method on our node. So we're getting there. Hopefully, if I did that correctly, we should now get, when I hit play, we should now get hello world. Oh, well, I have to assign an asset first. That would help. That would really help. Yep. All right. Where's our camera? Why is our camera not here? Let's move our camera so we're actually pointing at the. Okay. Cube. And let's put the CG default in there. And then hit play. And if all has gone well, we now have hello world. Hooray. So So big deal, right? We've built a node, we're executing nodes. All we now have to do is move to the next node, and that's it. We just can move through our node graph and get stuff going. This is huge. This is great. It's all been leading to this. My coffee is probably quite cold now. Yeah, it's cold. I've had the lid open. I should have put the lid on. But that's fine. Okay, no, this is great. I wish it wasn't raining. I'm so excited, and it's so dark outside and horrible. Okay, so all we now need to do is write our code to move to the next node, and then return the connection based on our output port. So what we can do by default is use this. Okay. What do I want to do here? How's the best way to do this? What we basically have to do here is look up. It's on our editor node. Connection. So what we need to do is basically check if there is a connection out of our port. Which should, in theory, always be port 0, no, port 1. Maybe we make the output port the first index, always index 0. Because there will be instances where we probably don't need an input port. There's probably never going to be an instance where we don't need an output port, flow output. And so we can then safely always try to move to port 0 in our flow. That's probably going to be the best thing here. Okay. So it's going to screw our connections up. So let's make that change, because we always need to go out. So I think out should always be the first port, and then in should always be the second. Because we can then safely be like, hey, get my connection to port 0, and just instinctively know that that's going to move from our output port. I think that's the safest bet to do here. So let's make that change. So let's go back to our graph and just remove all of our connections. I'm just going to delete this for safety, save this, and then go to our editor node and swap the instantiation over so that our output port is always the first one that gets created. I'll make a note. We do this so that output is always index 0. And because it's more likely that we're not going to have inputs than we're not going to have a flow output. I can't see an instance where we would only flow into an input. That seems kind of strange. So yeah, all right, I think that's a safe move. What I'm also, no, I think that's fine. Okay, so now with that there, then we can go back to our code graph node, and we can need to save the asset. We need to save a reference or a callback. Should instance the call. Okay, yeah. So we need to make the asset. Again, there's multiple ways to do this, so I'm just trying to think through the best way to do this currently. About since I yeah, I think this is gonna be this. Okay. We need to get a reference to, we need to reference the graph asset. So code graph asset. So probably what I'm going to do is make a private non-serialized reference code graph asset, because we need to get the nodes so we can move through them. And our actual node itself doesn't have any of the flow data, which is intentional, but it does know. We will be able to program based on the design. We know how the ports are all going to be set up. Again, you could do some of this stuff dynamically if you wanted to, but this is just how I'm going to handle it. You know what? Actually, let's not do this. Well, yeah, okay, I've got a new plan. What we're going to do is we're actually going to pass in the graph asset as part of the onProcess method. Yeah, that's how we'll do this. I was going to do it slightly differently, but I'm refactoring my design as we go along here. So because we need to get reference to our nodes, and so, but each node may want to handle data differently and get its own data differently. So we can't make too many assumptions here. But in our object, as we move through things, we can just pass in the graph instance. And then here, the base thing to do is what we should actually do. Yeah, do we want the node ID? Yeah, or do we get the connection here? I think we get the node ID. Okay, current graph, and then we can get the connection. So, cool. Yeah, okay, so what we should do then is, as our base process, we want to return our output port node. And so let's go into graph instance, because we graph asset, we need to look up, get a node from a connection rather than a. So we need public get node connected to output, or get node from output connection. Yeah, let's do that. Okay, and then we need the input node ID and the from input. I think this will work. No, output, because it's the output port. Yeah, from output. Let's just call it get node from output. So output node, and then put. I can't remember how I handled this on multi occasions. I think if there's multiple, we'll worry about multi connections in a minute. Because we can find all of the nodes that are connected that way. So let's do let's go through our connections. Node dictionary. Do we make a connections dictionary in here? No, because there could be multiple connections to the same node. There's my dog barking at noises. Okay. All right. So node from output. let's go get our node, and we can then get the. No, we need to get the connections. Okay, so we need to look through our connections to find ones that have this port. I think I'm just gonna do this. This is not the most efficient way to do it, but I'm just gonna go through all of our connections and see if we can get the matching. There should be, I think, as long as we only have one port connected at a time for now, which for our flow output it should be, we should always be fine because there's never going to be any other connection. I think that's okay. I may end up updating this in the future, but I think for now this will be fine. Okay, so we'll go for each connection. So if connection dot output port ID equals output node ID, and connection dot output port dot port index equals, should be a index. Index. Then look up the node. Then need to get the code graph node. Then we need to string node ID equals connection dot input port dot ID. We can then get that connection. Code graph node equal node equals. Wait, no, I think we can just return get node from out. You know what? I don't even think, because we need to just return the ID of the node to move to. So I think, well, no, let's do this because this value, this is a useful thing to have. Okay, so input node. I was going to do it one way, but like we might want the actual node data for other things that we want to do in the graph in the future. So let's do this let's do this normally. So we just do node dictionary dot. I think honestly, I'm just gonna do that because we shouldn't have an issue doing that, but it should be fine. It's risky, but it should be fine. And then return the input node. So we'll just return the first one. Again, this isn't great for multi-connections, but I have a way to handle that. I've just completely blanked on how to do it. So when we need to add that, I'll look into how I've handled that in the past. I think I've just like got a list. In theory, no, right. You're never gonna have the same node. It's irrelevant. It's always gonna be one connection. You can have multiple coming from the output, but you're never gonna have the same input connection. So that's fine. The node ID and the port that is the unique. You may have multiple. Yeah. No, this is fine. This should only ever return one ever because of how it's set up. Yeah, okay, this should be good. Because you're never going to have more than one port connected to the same node. That makes sense? So this should be fine. And you're never going to have more than two nodes connected in the exact same way. So the connections should all be unique. You just may have this. You may have multiple nodes connected to the same output port, but you're never going to have the same. I think it's fine. I am missing something. There's something I'm missing here, but I think it'll be fine for now. I will probably have to clean this up because there's a different way to do it, I think, but we're fine. I'm not going to hang on this much longer. Okay, so that should be what we need. So we should be able to do back in this side of things as our base. We should now be able to do code graph node, like flow next node in flow we should be able to do get, we should be able to do current graph dot get node from output. Our output is this is like mguid us and our port of 0. And then we should then be able to return, then if next node inflow doesn't equal, then return next node inflow dot ID. That should now work. So we then go to our start while. That should then have, we should fix this. Asset, current graph, current graph, pop the current graph in there as well. Then we should have hello world start. And because of the connection, let's then get our debug log node and override on process, and then do debug log move to debug log node. Cool. Okay. So basically what we're doing is in that process, we are in the process of move to next node, we call start node on process. That then should return the next node ID, because in our base sort of graph node, we just return the next node in the flow using this new method I just made, which is get node from output. By passing myself and the index, we should then have an input to move to. And again, we can safely know that that's not going to be more than one. Because it's that direction, it should be fine. It's like output grabbing the next input, that should be fine. You know, and in the other direction, it would also be unique, because if we were going the input grabbing the output, well, that nothing else is going to go into that input. So that's also should work then. That's what I was missing. So we should be good. Yeah, and so then once we've got that over here, we then just grab that node again and we move to it, and then we just do the whole thing again. And so yeah, if we build this connection, hopefully, if I've done this right, we should now have 2 debug messages that appear here. We do not. We have failed somewhere. Where have we failed? Node dictionary does not get the. Ooh. All right. Well, let's keep going then. Let's figure out what's going on there. Did those connections get saved? Did. Input port. I may have just got the connection logic tied up. So try and get value, get node from out. Okay. Debug log, base on process, that does this, next node in flow, embed, node, paragraph asset.get. Oh. I didn't. Did I init the dictionary? I'm sure I called. graph instance.init. Yeah, we did init. I'm calling. Oh, there we go. That's why mgraph asset.get node. There we go. We were calling it. I didn't replace it there. On the instance, that should be it. There we go. We did it. All right. Live, but nothing like some live bug fixes. But look, there we go. We moved to the debug log node. Okay, that's great, right? Cool. So now we have a flow state. We can move between nodes. We can do things. So you know, let's do something. Process and move. Okay, cool. So let's make a let's make our log message do something else, and let's expose a property on our log message so we can get it to say what we want it to say. I don't think I'll have time to move the object today. We might deal with that next time. But what I do want to do is expose the message. So in our debug log node, we'll make a string. And this is how we can start dealing with like exposing properties and adding fields inside of the nodes, because that's the final thing I really wanted to do today. And then I guess next time we can talk about values and we can do other things, because we've built most of the framework now, and then we can actually start building functionality into our system. So public string, log message like this, and then we'll do the log message. And so what we're going to do is make a new attribute. I think just exposed property. Let's just do that. Okay, so we'll do create a new runtime attribute. Probably doesn't actually need to be a runtime attribute, but it's in a it can be an editor attribute. Folder attributes. No, because it needs to go in the runtime node. Never mind. So create script. Exposed property attribute. Why do you instantiate the code graph asset in code graph object instead of using the original instance directly? Because the original instance is a serialized object, and if the code changes anything in that serialized object, that would get saved at runtime. And I don't want that to happen. So if we make an instance, it's kind of like materials. If you make an instance and you change that while the game is running, that gets destroyed when you come out of play mode. And so in general, if you're doing things with scriptable objects that you don't want to make changes to at runtime, make an instance, and then you don't have to worry about that, because the changes you make. So if you're editing things on the scriptable object at runtime, you won't make changes. So it's more a safety reason than anything else. But it also means you can have multiple things executing from that asset at once too. And you can have instanced data on that asset. So if I wanted multiple objects, which is kind of the design here, to use this graph and have the same behavior, they would all be their own instanced version of that behavior. So that's exactly why we do that. Okay, so let's now add our exposed. Did that? Exposed property. Oh, I haven't set this as an attribute. Right. Attribute. Don't need to do anything else. We can just do that. We could add other things if we wanted to. Exposed property. like that. And then in our editor node, we will look to see if that exists. So this is where we get field info for everything on this type. So we have the type yet? Type info. Okay, so we do for each field info property in type info get type. Oh, sorry, get fields. Type fields plural, please. And then we go if property dot custom attribute exposed property, then wait, there was a way to do, maybe I set this up earlier. Is it as? Yeah, there we go. Exposed property. Is that it? It is. Ah, it is. There we go. Okay. So property.get custom attribute exposed property is exposed property. That should work. Let me just test that. Property.name. I think that would show the member info. So for the debug log, what we're going to do now essentially is just expose fields inside of our, there we go, log message. Expose these fields inside of our node so we can actually edit them and make changes. So there's different flows that you want to do, but it's essentially so we can do things like this and we can have data that we can adjust and edit at runtime to make changes to our graph and, you know, do things like that. So this is the kind of last little step here for building the complete base functionality of our graph, what I consider to be mostly complete at that point. So what we want to do then is called draw property, make a method, and we'll pass in our property. I believe that's what we want to do. Property dot name, and then we'll do yeah, no, that's it. So we can draw the property for that one. And gives us back a property field. That, do that, and that should be pretty straightforward. Should be able to bind it using name property, and go if. Oh yeah, we need the serialized property. Okay. Okay. If m underscore serialized property, just bear with me here. This is because of annoying UIToolkit like serialization stuff that we have to deal with bindings and whatever. So we'll fetch the serialized property. So we can get the base property from the object of the asset. Let's make a variable for that. This is some boilerplate stuff that I'm just from my other graph tool. It's kind of just boring, annoying stuff. Yeah, so we need a serialized object as well. Okay, so let's do that. It's basically so that each node can be serialized with data. So making the serialized passing that in when I. Okay, we can just do that. All right. That keeps everything in sync. So we'll make the serialized object the code graph object, and then we'll make a public. It's private. Okay. Serialized object. Part of this serialized is m_serialized object. And then we set that equals code graph object, and now have that reference. So when we're trying to fetch our serialized property, we can do that. It's not called mesh graph nodes, it's just nodes. And that should then allow us to find our node by its GUID. We've then got that as our serialized property, which we can then use that to extract the property from. And then that should allow us to just for our property name of the node. So what this is basically doing is it's grabbing the serialized object, which we'll pass in a minute, finding the node array, going through each of them, and then in each individual element getting the GUID. I think it's just called M. I think I kept that the same so that m_GUID. Yep. Okay, cool. So then if that matches, yeah, if those two match, then which is what we've got up here, graph node. Yeah. So if the ID matches with the string value of the GUID property, then that is our serialized property. So we can fetch it. And once that's been assigned, then we can just draw the field based off of that. So property. It is just as simple, I think, as creating a serialized property prop, and then we do m_serialized property dot find property relative. If you've done editor tooling stuff, this should be pretty similar with you. So we'll call this property name. Property name like that, and then we make a property field. And just do new property field. We pass in the property like so, and then we do field.binding path equals prop.property path, and that's UIToolkit stuff. So it's bound to that part of the serialized object, and then in the extension container we then add this field. And then we can return it in case we want to do anything to it, like so. This is where it gets a little bit gnarly, because when you delete nodes, all of these binding paths get incorrect, so you have to kind of rebind everything. Really annoying. And I wish it had a much smarter. There was a much easier way to do it, but still no real way to do that. So you have to like go through and redraw everything whenever you delete nodes and stuff. It's not great. We'll handle that in the next episode, I think, in the next stream. But this should be fine for now. So the last thing we just need to do then, field.draw property, and we can do stuff with that later. I don't know if we need to do anything else. Get that working. I think we're fine. No, we need to register the value changing. Okay, so field.register value change callback, and then go on field change callback. And then I think we do need to I think we're okay. So we'll create a callback, and oh no, I think we're okay. Yeah, I think I don't actually think we need to do that. No, I think we're fine for now. We might want to use that. I'm going to comment that out for now. We can come back to this if we need to do any update stuff. Sometimes if you want to make changes to things, it can be useful to get callbacks, but I think that's actually okay. So just back in our asset, we need to pass in our code graph object anytime we make an editor node. So our view, code graph view, should have some errors in it. There we go. And do we have the serialized object here? We do. So we need to go m underscore serialized object, like so. That should now work. It did not. Why not? Did I not add a oh, maybe. Well, we've got the exposed property in the log message. On the process, we will debug log the log message. So what have I missed? Let me close this and open it again. Nope. All right. Let's check the debugger. Because this should be exposing why don't you see this? Code graph editor. Is it there and just not showing? Did I not add it to the right element? Maybe it is there. Oh, wait, hold on. Contents. Top. Oh, there isn't a content container, that's why. Oh. All right. Is that? Did I add it to the right container? Code graph editor node. You know, draw property. Let me check that I did. Extension container dot. Empty container used to display custom elements. After adding elements, call refresh expanded. Oh, wait. Extension. Property field. There we go. Ah, I'm not calling bind on the graph. That's why. Okay. Yep. Refresh expanded state needs to go in. That's why. Okay. So you have to then bind the data to the graph. Okay. So at the end of that, we call refresh expanded state. And then code graph asset bind. So anytime we add node, code graph object, bind to the actual code graph view. Here we go. Let's make a bind method. And that is just m serialized object dot update. And then we do this dot bind because then we bind the serialized object to element. Oh wait, it's already okay. That wait. Yeah, I guess that makes sense that I can't do. Wait, can you not do that anymore? No, that's it. There we go. I guess it just didn't import. I needed the namespace imported, I think. Yeah, probably. Okay. So then when we add a node, we can just call bind like that. That should work. It did not. Let me close this. Let's try again. Still didn't work. Why didn't that work? Ah. Missed something? Let's check that it's actually calling the bind method. Okay. Oh, is it only going to happen? Oh, there we go. Okay, yeah, right. Okay, I just need to put it in more places. Cool, it does work. It just needs to go in draw nodes as well. After draw nodes, there we go. And then we do it when you add a new node. And that should be everything we need to do. Yeah, it's in draw nodes. After add. And that's it. Okay. Cool. So then if we do a log message, and I'm not a fan of that, but all right. We'll deal with some visual styling here. This is a test binding. Let's see if it saves. One thing to do, this is the weird thing with these bindings. It should have saved to the object. We can check. Hello there, this is a test binding. Great. So there we go. It updated. Perfect. So now, because in our method for our debug log node, we have the log message, that should now allow us to display the message that we just typed in. There we go. Hello there, this is a test binding. Perfect. Okay, so now that those two things work, we're basically done. So if you have any other questions, feel free to ask them. I'm just going to do one more thing, but feel free to populate any questions you have, anything at all. Feel free to ask. We're going to wrap up within the next 5 or 10 minutes or so. So, but we're there. We've done a huge amount today. This is like, we've now got a functional graph. You can probably run with this if you are satisfied with everything. There's so much more we can do, but there should be enough of a base here now for you to work from, which is really what I wanted to achieve. So I'm really, really happy we managed to get to this point. So the last thing I'm going to do is just add a brand new node, just to show you how easy it is once we've done all of this boilerplate to just add more functionality into the graph. So let's create a new C# script called, I don't know, move. Well, we don't, yeah, move. Let's just make a move node, and we will just, because this is only going to execute on enable, we probably want to make, in the next episode, we'll make actual nodes to execute based off of the Unity events, so we can have things on update, and we can execute code on update. But for now, we'll just stick to this. So we'll make this a code graph node, and then we'll add the node info, and we'll call it move self, and we'll make this transform, I guess. Oops. Transform / move. And then transform / move self. And yeah, it'll have an input and output, and then we do override process. We'll make a public vector3 offset, I guess. Whatever I want to do. Direction. Make this a expose property. And then in here, we just go, we need a reference to our assets. We need a reference to ourselves. So in our code graph asset, let's make a reference to our object. So let's go, just do public game object self, and then let's do in the init call, we'll do that, and then we'll make self game object. Actually, I mean, let's just call this game object, because why not? That way we can reference it. Because then in here we can do current graph dot game object dot transform dot position plus equals direction. There we go. And so that now should allow us. Okay, we didn't put this in here. Game object like that. So we now have passed the game object to the instance, so we can now perform code-based changes inside of our nodes. Then if I go into my graph, and then we go here, and after our log message, we make a move self. Then in here, we can move up by 100. That's probably going to be too much. Let's do it by 10. Save. And then if I hit play, our cube should no longer be touching the floor. It is not. It is up there. The camera just can't see it. Great. Cool. Well, look, I mean, that's great. And then if we stop, it's now back down where it was. So there you go. That's visual programming. That's building. Oops, sorry. That is that's how we build a use GraphView API to build a little visual scripting tool. It's very bare bones, but hopefully that gives you the gist to really get started here. There's clearly a lot more to do, but I think what I've covered over the past 2 streams should show you how to get started with a graph tool, and then manage data, and then execute that data. And that's really what I wanted to try and show off here. And please leave comments if you're watching this after the stream of anything else you'd like to see. We'll do one more stream to just tidy things up, make it look better. We might do some property-based work so we can have like vectors that we can share across things and maybe save to a Blackboard. I think a Blackboard is an important part, so we'll probably do that in another stream. But the key part is we really have, we've got the data management here. So from here, you should be able to run with it and build kind of any graph editing tool, whether it's for shaders or for code or for a build pipeline or, I don't know, dialogue tools, state event management, behavior trees, etc. You hopefully can see from this basis that we've spent over the past probably combined 6 hours or so, just under, that in a day you can get a tool working like this and add a bunch of functionality. And as you saw from adding in that tool, like that extra node, it really was all of this work to support adding in nodes like this. I did that in 10 seconds, 20 seconds maybe, to just add a new node into the system, write some code for it, and it just kind of worked. And that's really, really why I like this sort of workflow, because once you've built the boilerplate and got the tool working, the reflection system that we've built with the attributes and everything help us get from instance new content and data into the system really quickly, so we can add new functionality to the system in mere minutes. And so it's all of that sort of upfront boilerplate work, but ultimately, hopefully, a big payoff. So, once you've got it running, we can now add nodes really quickly. We can add, functional nodes very, very quickly. So next stream, we should be able to add additional features and functionality with very little work. We'll just have to do a bit more boilerplate to get like Blackboard stuff working and save properties and things like that. But yeah, that's it for today. So let me just answer a couple of questions real quick. Feel free to ask some while I'm answering. I'll go back through the chat real quick. But yeah, hopefully that's really helped you. Let me know your thoughts, obviously down below or in the chat here if you're watching, because that would be, I'm just really curious if you've found this useful and helpful. Because like I said earlier, there's no documentation on this really whatsoever, and I've pieced together a lot of what I've known through sheer brute force and through other people's GitHubs and things like that. So I will be sharing the Patreon package to people over on Patreon. So if you are a Patreon member and you're in the packages tier, it's going to be available. This specific build will be available. Just check it out. I'll link below after the stream to that post. If you're not a patron, please do consider supporting the channel so that I can do more things like this. That's really appreciated. If you found it useful, I would love for you to join. But yeah, let's go over some quick questions. I'll write it again because I want to answer from you. Okay, thanks. Why do you sometimes write properties, not fields, with Pascal case and other times with camel case? Just depends on how I feel. Usually I'm writing Pascal case port like if it's just a getter, and then if it's a Boolean, I like the lowercase aspect of the question part of it, but it's really just how I feel at the time. I said this during the stream. It's just, you know, there's some instances where I'm very strict on what I do, and then others I'm just more verbose. I just like verbose things, and capitals usually make me aware. Like Pascal case is like, okay, no, this is an object that I'm fetching, and I tend to use camel for sort of more data, I guess, but it changes. It just really depends on how I feel at the time. If I think it looks better, if it's like a single word, I tend to use Pascal case. So it's just ports or nodes or something. If it's multiple words, then I tend to use camel case. That's really usually, I think, how my brain works in the background. But yeah, is it possible to directly assign scriptable objects onto node fields, or do I have to go through Blackboard and write data? No, yeah. So you can you can have things in there as scriptable objects to fetch other data, which is something we can show. Basically, now that exists, the expose property will allow us to draw anything that Unity can draw as a property, and that can be data that we can manage inside of a node. So if we did want to do other things, you know, with how nodes are managing data, then that's great. You can use scriptable objects. For instance, maybe we can have a scriptable object for like some other, like a prefab instancing something or other, and you could use that. Scriptable objects are endless, but yes, you can use those as properties because it's just an object that Unity can draw. So it's really up to you how you're going to want to use that. Maybe we'll do something with that next episode. You're creating an instance of an entire node graph node. If I'd want to create the nodes at runtime with factory, will there be any? I don't know how to do anything of this at runtime. This is all editor stuff. I think if you wanted to. You could technically look up the structure and then rebuild that at runtime if you were trying to use it that way. So if you're just using it as a data structure, and if you're like, okay, this just needs to look like this, then I guess you could just do the processing that I'm doing, but run it all at once and just use the connection info and the positions of the objects, because that's stored on the actual data structure. And then you could rebuild that at runtime in theory. Yeah, I think I saw you saying you wanted to use it for like a tech tree. I think you could do that. You could build the tech tree as the editor tool and then use that data to repopulate that at runtime, but you'd have to explore what that looks like. So yeah, Graph Tool Foundation, I mentioned this earlier. There's nothing about that. It's been in the works for a while. GraphView is the current thing that exists. So as soon as GTF exists, I'm sure I'll talk about it because I'm a big fan of these graph workflows. But it's Unity's intent to replace everything we're doing right now and all of the graph related tools to this foundational API. Unity are just very slow at doing that. So we'll get there eventually, and I'll talk about it at some point. So is it okay to fill your portfolio with physics simulations? Well, it depends on what you're applying your portfolio with. If you are trying to become a physics engineer in a company, then I think that's probably expected. If you're trying to just be a programmer, I think most people would be more interested in seeing actual demos of full game projects that you've worked on, or game jam projects, or etc. So it just kind of depends on where you're applying. All right, that seems to be most of the questions, I think, that I didn't answer during the stream. Yeah, I think that's probably it. Okay, cool. All right, well, let's end things here. As I mentioned, thank you for watching. I know it's been a long one. Hopefully this has been helpful, and yeah, just let me know your thoughts down below. I'll have a new video up on the channel probably before I do the next stream. It might be a while before I do the next stream because I think we've covered most of it in these two, and I think this gives you a good foundation to work from. But yeah, if you want to support the channel, there should be links down below on you know, ways to do that. Come join Patreon. There's some exclusive posts there, and yeah, this package will be available there too. So yeah, thanks very much. Enjoy the rest of your day, and we'll see you again in the next one. Bye guys. Bye.